All right, ladies and gentlemen, this is going to be a very down and dirty, quick video going through our recent quiz. I apologize for the quality. I'm actually not feeling very good, so I'm just putting this together in the hopes that it'll help explain. One of you has emailed asking if we can do this, and I apologize. I have not read your journals for this yet. Again, I'll be out of it for a bit of time, but I'm hoping this is still going to be helpful even though I'm a bit out of it. So let's see what we can do. Well, maybe I'm too out of it to do this. I don't know. There we go. All right, resetting. All right, so what's the difference between descriptive statistics and inferential statistics? Well, inferential is like looking towards a population, making decisions, or trying to describe something based on the sample. And descriptive just describes what we have in the sample. So descriptives describes what happens at the sample, discusses, inferential guesses at what's happening in the population. Great. I will say again, I don't pre-check these, so I just kind of hope at the end that these are right. But we'll see. Key difficulty of inferential statistics central limit theorem solves. Well, in guessing about a population, we never know what the distribution is. So central limit theorem is helpful with the distribution stuff. So determining the distribution of the population. I guess we can read the others, but I'm pretty sure that's going to be it. Integral of the normal. Well, this determines the distribution is the normal, but the central limit theorem itself isn't helpful for evaluating an integral. Whether center of the population is, actually that one we know pretty well. Which measure of center to use for the sample. Yeah, this is going to be the one, determining the distribution of the population. That's what the central limit theorem solves. And again, this is a very specific for population. It's the population distribution for the means, typically. Central limit theorem says, well, again, it talks about the distribution and it talks about the normal distribution. But let's look at these others. Range of integration, no. Should use mean for the center of the sample. Again, this is contextual. You know, if we've got a lot of outliers, mean is a bad decision, but central limit theorem doesn't talk about that. Center of populations at mu, no, that's just notational. So yeah, this is going to be it. Two ways we implement inferential statistics. I actually don't know what we're looking for here. Oh, probably confidence intervals and hypothesis tests. These are the two kind of broad categories that we look at in inferential statistics. That makes sense, I guess. Standard errors, point estimates, predictive analytics forecasting. Well, these are ways that we can do inferential statistics, but yeah, the two classifications, probably confidence intervals and hypothesis tests. All right, determine which of the best of low align with CI and HT. Put our data on the scale of the distribution. Ooh, well, I sure hope we talked about this in the videos. I believe we did, but honestly, I can't remember one way or the other. So data on the scale of the distribution. Oh yeah, well that's kind of the whole point of not a confidence interval, of a test statistic in the hypothesis test. Takes our data, puts it on the scale of the distribution. Distribution on the scale of our data, well that's the whole thing with a confidence interval. Reasonable range for the parameter. Well, confidence interval is all about a reasonable range, and make a decision with blank confidence. Well, decision making is hypothesis test. Though I will add quickly, remember we can make a decision with confidence interval too. What's the standard normal? Well, it's just a normal with mean 0, variance of 1. So there's a couple of things here, but we'll a fancier name for the normal distribution. I like that. Some weak distractors here, I apologize, but yeah, it's a specific normal distribution with a mean of 0 and a variance of 1. Which of the following best describes the sampling distribution? Well, remember the sampling distribution, we can have it for mean or standard deviation. We typically do it for mean. And it's like, what's the distribution of the means? So sample looked like, different sampling method, no. Distribution of a statistic calculated from sample, yes, probably. Distribution of what our sample would have looked like if we'd have taken a different sample, no. But this one's actually kind of close. This would be, well, no, maybe not. distribution of our sample rather than full population? No. So this is it. Again, we're looking at the distribution of a statistic calculated from the sample, and this is what that's what a sampling distribution is, I guess. All right, using statistical distributions connect what two concepts? Yeah, that's a good question. Point estimates and confidence probabilities. No, probably not. Um, confidence probabilities to cut off critical values. Yeah, that's probably it. Point estimates to standard errors. Standard errors to cut off critical values. This is a hard one, but I think this one is going to be confidence probabilities to cut off critical values. So think about our distribution. When we use a distribution, kind of think about what we do with it. So we've got this distribution. What do we tend to do? Well, we have a confidence probability or percentage that we want to involve, or an error rate, which is the inverse of that confidence probability. And then we want to do that to get cutoff for critical value. And so this is the connection from our statistical distributions to go from our probability to critical values. All right, which of the below most closely resembles the concept of a standard error? Well, remember, standard error is just the standard deviation of the sampling distribution. So looking for one that says something like that. Standardization formula, an error, difference between population and sample. I don't really know what that's talking about, but it sounds fancy. Spread, specifically standard deviation of a statistic. Yeah, there we go. Okay, that's the one. Percentage wrong, we're comfortable with. Nah, that's our type 1 error rate. Least amount of error that we allow in inferential statistics. That's our I don't know what that is. I guess maybe that's the nominal error rate. I don't know. Anyway, yeah, the standard deviation of a statistic. Again, we typically do means, e.g., exempla gratis. That means it's one example. What we typically do, taken from different samples, all from the same population. Yep. All right, which following components are being used with hypothesis test confidence intervals? Well, we're definitely using variance standard deviation, not range. We're using mean, not mode or median or IQR. So variance and mean are what we're using with our classic hypothesis test and confidence intervals in the class. So in the following situation, you currently sit in an executive meeting, blah, 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 analytics team, 90% confidence interval for average revenue per patient, $500 to $1,000. Okay, cool. Coworker says, great range to have 90% of our patients in. What's the problem there? Oh, that's a good question. So it kind of goes back to what is a confidence interval. So our confidence interval isn't like the fact that you have a 90% confidence interval of this range does not mean 90% of your patients are in there. In fact, the higher the sample you have, the more narrow this confidence interval is going to be, and the more of your patients are not going to be in that, because this is talking about a mean. It's not talking about 90% of your patients are in there. It's one of the big limitations, actually, of statistics, broadly speaking, is that we do great prediction for averages, but it's very difficult to predict individuals. And I apologize, I can't remember how much we talked about this in your videos, but it's one of the reasons that we predict group averages so often. I'll say again, the reason that it's so hard to predict individual scores is because we don't know the distribution of individual scores. And the only reason we can do group averages so well is because of that central limit theorem, which we had a question about above. So in any case, yeah, this is definitely not 90% of our patients are falling in that interval, even if we're 90% confident. So let's see which one talks about that. So confidence percentage or more. So no, that's not the problem. It's that it's more than 90%. Regard confidence, the population mean lies in the interval. Yes, not percentage of individuals who lie in the interval. Yes. That's it. Calculated using a sample. We can't make decisions. Well, remember, the whole point of inferential statistics is to make an informed decision about the population using data from the sample, acknowledging the uncertainty that our sample could be incorrect, and again, making that decision with a certain degree of probability confidence. So we need to make a decision. We want to use sample data rather than just making this up. Um, for making a decision about the population. So this is kind of the whole point of inferential statistics, is using a sample to make decisions about a population, while at the same time acknowledging the uncertainty inherent in that process. Can't make claims about the population without a formal hypothesis test. Well, that's an interesting thing. You can't make it without inferential statistics validly, but without a formal hypothesis test, well, confidence intervals make claims regarding the population mean. So hypothesis test is not the only way to make claims about a population mean. Confidence intervals do too. Uh, Formal hypothesis tests are for decision making, but again, we can use confidence intervals for decision making too. These are two sides of the same coin. Remember, they both use the same core components within them. Um, and so again, these are just two sides of the same coin. Hypothesis test, we compare our data to a distribution made from, okay, test statistic, other samples we've taken, the alternative hypothesis. Oh, I see. So what is the distribution we're comparing to? It's the distribution from that null hypothesis. So essentially, we look at the distribution from our default belief and say, how well do our data align with our default belief? When we make a decision using hypothesis testing, no, we make the correct decision. Well, we never know. Blank confident we made the correct decision regarding the null and alternative hypotheses. That sounds right. No, we made the correct decision. Can never know. We are blank confident that the null hypothesis is false. Okay, so I'm looking between 2 and 4. So which one sounds more correct? The null hypothesis is false. Well, no, I don't like that. Made the correct decision regarding the null. Yeah, so I think this one's going to be the direction we go. The null hypothesis is false. Well, the null hypothesis is either false or true. So we're not blank confident the null is false. We're more making a decision regarding these comparable hypotheses. So that's the confidence we're more speaking to here. Difference between critical value and p-value approach. Well, critical value calculates the critical value from the distribution and then compares it to the test statistic. P-value uses the, well, essentially test statistic and then calculates the probability of that or something greater, more rare than that. So critical values when we're not sure the hypothesis. No, probably not. Critical value more prevalent with modern computers. Actually, this is false. I mean, the big advantage of p-value is that it is probably easier to interpret than the critical value approach. It needs less information, or it has to provide you with less information as a user. So the p-value approach is actually much more prevalent with modern computers. So this would be correct, but it's phrased the opposite way. Critical value approach compares the test statistic to the critical value. Okay, yeah. P-value approach compares area more extreme than the test statistic, i.e. the p-value to alpha. Yes, okay, so this is the correct one. It's kind of the textbook definition there. And then critical value gives the exact answer, while the p-value gives it approximate. Yeah, that's not true. All right. So wish to determine average revenue per patient in a new urgent care center. To get a reasonable range, you wish to create a 95% confidence interval for this average. Some sample data, what critical value should you use? So you know what's funny, y'all? I wasn't sure if I should tell you this or not, but I figured I would because I want to make this less mysterious. You know, I'm not a magician. I do this stuff all the time, but I think I've mentioned earlier in this course, while I use Excel somewhat regularly, I don't use Excel for statistics very often. I have statistics software. The main one that I use is called R. I use it because it's a little easier to do some fancier stuff, but it involves coding, which is why we don't use it in this class. I say all this now to say, how do we calculate the critical value in Excel? The truth is, I can't remember it all. So what I do is I go back to our notes and check that out to see what it is. Now, if I went back to the Excel video, quite frankly, I don't go online. I don't go to Google. I go to this class's notes because I do make the notes in this class to pair with these questions and actually vice versa. I look at what we've done in class and then come up with these questions from it. So everything should be in there. And so I think I'm looking for norm s inv. And again, I'm not making this up. I actually didn't even remember it before recording this video. I just wanted to figure out how to do it, and I couldn't remember. And so I went back to watch the Excel video on how to do this just now, and saw that it's this norm s inv thing. So 95% confidence. Well, in our video, we talked about making a little cell called alpha. I actually kind of like that. Maybe we can do that here, alpha. And then I'm going to put in my alpha value. And then I'll do the cutoff, or maybe what do we call it, the critical value. And so this is what we did in the video. And I'll just do it here too, just because norm s inv. And then we did alpha divided by 2, because remember we have half of the alpha on the bottom side and half of the alpha on the top side. So if we took alpha, the 0.05 divided by 2, was this 0.05 in this example? What is our alpha here? Yeah, 95% confidence interval. Alpha is 0.05. So alpha divided by 0.05 divided by 2. So you could just do this in another cell if you want to see what that is. Alpha divided by 2. That's 0.025. Okay, yeah, and remember we've got two sides of the curve, so we want one side to be 0.025, so 2.5%, the other side to be 2.5%. And so that's why we're doing the inverse of 2.5% on the bottom end. That's asking what's the critical value, the cutoff for that area on the bottom there. And this one asks for it on the top. I know in the video we also did this. How do we do it for both? So we do 1 minus that alpha over 2. And again, if you're ever curious about what these numbers are, just go over here and type 1 minus the alpha value divided by 2, and you'll see it's essentially 97.5% because it goes to the left. So we've got that 2.5% on the right. That means 1 minus that, or 97.5%, is to the left of this vertical mark if we think about it. So 97.5%, that gives me this positive cutoff value of 1.95, 1.96. So I'm going to copy and paste that over. And you know, I've actually quite liked, I didn't know this when I made these quizzes, but just copying straight from Excel has been quite nice for Canvas. And again, don't worry, I get some emails from some of you about the decimals. Very rarely is that the case for your answers. And for all of these answers, I do build in some wiggle room. So if you typed in 1.95, that's not going to be a problem. What'll be a problem is if you type in like 1.2. Well, that's not the correct answer. So don't stress too much about the decimals. But that said, I just copy and paste straight out of Excel now. I quite like that. I think that's pretty cool. I also realized in the last example video I showed you how we can copy data into this into Excel from Canvas pretty easily. I actually prefer that to the method that I showed you in Word. Now I will say the Word method is really cool because it can apply to a whole bunch of delimiters. So I use that weirdly. I mean, it's a weird little kind of hackish method, the one we talk about in the Excel video, but I really like that because it can apply to whatever delimiters, even ones that Excel can't typically handle. So it's a good one. I'm glad we talked about it in this video, but for me, I prefer the method in our last solutions video personally. All right, wish to determine the average number of ED visits per day. To get a reasonable range, you want to create a 99% interval. Okay, what critical value should you use? So I'm just going to go back to my Excel value. 99% interval is 0.01 error, and all this just automatically updates. I have 0.5% error on the left. That's half of a percent, less than 1%. And 99.5%, again, that's half of a percent on the top, means 99.5% on the bottom. I'm just going to copy that over. Again, all I'm getting this from is our videos. When I'm copying over, you'll see it carries over a ton of decimals and then it ends up rounding. Why it went to 2 digits here is because rounding to 4 digits actually rounds to 2. You'll see these Well, it's not there now, but you'll see those digits actually round to 1.96 when rounding to the 10,000th place. All right, colleague wishes to conduct an examination to determine, agrees to collect this. Another critical value question. Great. Well, I mean, I didn't mean to put this many in there. I guess these were confidence intervals. These were hypothesis tests. What's the alpha level here? 0.2. Man, this little program's getting me a lot of points here. 0.20. So I'm just going to pick the positive one, right? Only list the positive one for all these. Yep. And then looks like a similar problem, alpha of 0.10. What critical value should you use? So I'm just going up here, 0.10. So when I make these quizzes, because it's hard to do partial credit in an online quiz like this, what I do is I break up the problems. So for instance, for a confidence interval problem, we need to calculate the critical value, then we need to use that to calculate the standard error, and then we use that to calculate the full interval. So we break that into 3 different problems to give you partial credit in a similar way to how I would give partial credit if we did this in an examination setting. So if you're wondering why there's so many of these, it's essentially to give you partial credit, and it's partial credit for a confidence interval problem and partial credit for a test statistic problem. Though again, that turned out to be, if you're using the method that we showed in the Excel video, that turned out to be some free points there. All right, examination of the new cleaning procedure for building costs. Is this a prominent practice? Evaluate it using alpha equals 0.20. The null hypothesis is blank. Given this, what's the standard error? Okay. So first, I need to remember what the standard error is. And again, you can go to one of several videos. To me, I was in that Excel video and I just saw that we did the standard error and said we need the standard deviation of the data and the sample size of the data. And those were the 2 pieces of information that we needed to calculate the standard error. The standard error was the standard deviation divided by the square root of the sample size. So here, I'm just going to copy these numbers. You can use the method that we showed in the video, or you can use the one that we showed in the previous answer video. What was that? All right, if I remember right, it's data. We did text to columns delimited, and then the space delimited. And I always double check. Oop, and see, I did that wrong. It should not be space delimited. Control Z to undo. What should it be? It should be comma delimited. That's better. You'll note if you want to go back and look at what just happened, when I did space delimited, all of these had commas after them, which Excel would not have liked if I tried to use them. Because if it has a comma after it, Excel reads that as you're writing something. It looks at it as words, not numbers. All right, but this should work. So here, I guess I could manually count how many things there are, 28 things, or I could manually count or look at the bottom of my Excel here, it says 28 things. But I believe we use the count command, and again, I don't remember any of this, I'm just kind of making it up. Control, Shift, and right to select everything in a consecutive order, and then close parentheses, enter, and I get my count from my sample size. Standard deviation, STD, dev, and I'm double checking again, so estimate standard deviation based on sample. And then again, control, which is going to jump me back and forth in a consecutive grouping of numbers, shift, which is going to make the selection, and then right to jump to the right. I'm going to scroll back, close my parentheses, hit enter. That's my standard deviation. And then for my standard error, I take the standard deviation divided by the square root, SQRT, of the sample size. And that's it. There's my standard error. So I'm just going to copy and paste this over and hope they have 10 more standard error questions. Actually, they do have another standard error question. That's great. Okay. So determine average revenue per patient, get a reasonable range, calculate a 95% confidence interval. Okay. Oh, I see. So this is standard error for a hypothesis testing. Again, they're the same information pieces. So it's the same calculation, but this is partial credit for the hypothesis test up here. This is partial credit for the confidence interval down here. So for standard error, you'll note this the null hypothesis, the alpha, like the 95% confidence interval. This is not information that's needed for the calculation of the standard error. It's important information when I put together the whole confidence interval, the whole hypothesis test. But for this one specific piece of information, I'm not using any of that. I just need the standard deviation and the sample size. And I mean, I could remember that from my notes, but I just remember that from the Excel video that I just watched to double check on how to do all this in Excel. So there's a couple of ways to do this. You know, I guess I'll make a new set of numbers here. You can make a new sheet for a new problem. You could delete these previous numbers. I'm kind of tempted to do that, frankly. Just plug in the previous numbers here, or plug in the new numbers here instead of the previous numbers. Yeah, I'm gonna do that. So I'm gonna delete those. I'm gonna just put the new numbers here, do text to columns, and I'm hoping this will just automatically calculate this out. And so I'll be done real quick. Okay, except this looks like it has 20 numbers, or it says it has 20 numbers, and I don't believe it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh, I might be wrong. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, I'm wrong. It does have 20 numbers. So I just want to make sure that this is reading in the correct information. That is, this is counting everything from A7 to AB7. Now it should only count when there's numbers here. So if there was a number here, that should change the count. But they're not. It's reading all of this as blanks. So this should hopefully work. And that makes it kind of easy. You could also have copied and pasted these equations down and done that, or you could take the extra 20 seconds to redo these for this new number set. But if you want to be super lazy like me, you can do this. All right, the hospital felt emptier this year for some reason. Generate null. What's the test statistic for this calculation? Okay, so now I need to figure out how to make the test statistic. And so for this, again, I'm going to go back to my Excel video. And it's not because, I mean, it's not really because of anything. It's because I just want to make sure I'm doing this, and I want to make sure I'm doing this in the same way we did in class. But for you, I want to make sure that you probably want to make sure that you're calculating it correctly using our analytic tool for this course, Excel. All right, so let's do this real quick. And so there's nothing up my sleeves here, y'all. Again, I'm just going back to my Excel video, checking this out, seeing. So I'm going to go and copy the data over. I'm going to put this in a new spot. I'll do my data text to column. Again, you can do what I demonstrated in the Excel video. Go to Word if you want. Either way, whatever's more comfortable for you. And so for this, I needed let's see, the point estimate. I needed the null mu value, and I'm just pulling these from this sample video. What else did I need? I need the standard error, and that was calculated from the standard deviation and the sample size. I should be using lowercase n for the sample size. I apologize. All right, so null mu, what's the null hypothesized value? That is 7 empty beds. Is that right? Let me read the problem again. Felt emptier. So collect data on the number of empty beds over a period and evaluate. A null value, 7 empty beds. What's the test statistic? Great. So the point estimate is going to be the mean of all of these values. So that's average in Excel. This is one I often forget. I think I forgot it on the last video. And the standard error, well, we just worked through this. This was the standard deviation of this data. And all I'm doing off screen here is doing the close parentheses. So I'm doing the, let's say, count. I'm hitting the tab key to auto-complete. Going to this, hitting Control, Shift, and right at the same time to highlight everything, and then closing the parentheses, and then hitting Enter to go on and calculate that. So there's 30 numbers. Standard deviation is that. Standard error is going to be my standard deviation divided by the square root of the sample size. And then my test statistic is going to be calculated based on all of this information. Test statistic is going to be, and I'm doing parentheses divided by something else. And if I remember correctly, it's the point estimate minus the default value, the null mu. And then I'm going to go click into here so I can click over, divided by the standard error. And that's the whole thing. So this is my test statistic, 2.867. All right. All right, given the sample data generated below, what's the test statistic? And I'll say for me, I actually read this part before I read the rest because I just want to figure out what the heck I need to do. So I need to generate the test statistic again. So this process is going to look very similar. Um, reduce building costs, promising practice, evaluated alpha equals 20. Well, again, you'll note in determining the test statistic, I'm actually not using my alpha or my critical values here. Now, we did practice calculating them earlier. What I would do for the critical value in a hypothesis test is compare my test statistic to this, but that's not what this is asking me to do. This is just asking what is the test statistic for this calculation. So I'm going to do exactly the same thing. I'm going to copy my data, come down here. I'm tempted to maybe show you what will happen because I think this looks like more numbers than previously, 30. So let's look at what will happen if I try to copy over and use the same equations. Well, maybe this isn't more numbers. It looks like it's not more numbers, so that worked out. In any case, I was trying to show you something that might happen that's bad, which would be, this says 30, but if I go and manually count, there's actually more things here. I can see this goes out to AB, so if I want to double check what this is going out to, I could see how far is this going out. This is going out to AD. So I could go in and just change these reference cells. It's starting at A16 and going to AD16. That's AD16, this guy right here. And so this is going out. But right now, it actually looks like it's working well. I will say the null mu right now does not look correct. So the null mu here is 47. I see my point estimate is 37. So those are 10 away. And so then I plug in these values, point estimate minus null mu, divided by the standard error. And again, all this is auto-calculated already. But the process is the same. Equals count for n equals stdev.s, and then selecting the data for the standard deviation. The standard deviation divided by the square root of n for the standard error. The point estimate is the average. And then down here, I'm just combining the point estimate minus the null mu divided by the standard error. The null mu, again, is coming from that null hypothesized mu value. And then copy and paste my answer over. All right. All right. Determine average revenue per patient in new urgent care center to get a reasonable range. You wish to calculate a 95% confidence interval given some sample data. Given the generated sample below, what's the lower number of the confidence interval? Okay, so this is asking me to kind of combine the whole process, and I've got a few numbers coming up here combining the whole process. So this is the whole confidence interval process for a 95% confidence interval. So I'm going to go on, do my first step, copy my data over, and actually maybe I'll make a new sheet here just to keep things clear because I had some old work there. And for a whole process one, this is going to take some space. We could, actually, I'll tell you what, I'm going to paste this in B and then do my text to columns again, delimited, comma separated, finish. And then I'm going to highlight, Control C, and then go to this first cell and transpose, and then delete this old data. So this is how I had it set up in our example in Excel. So for our confidence interval, we need our point estimate, we need our standard error, or excuse me, we need our critical value, we need our standard error, and then we need our standard deviation, and we need our sample size to calculate the standard error. All right, and actually looking back at the video, it looks like I need my alpha here too, so I can calculate my critical value. All right, and so now I just go on and start putting the pieces together. And so it says a 95% confidence interval, so I'm going to go ahead and put in alpha equals 0.05. That's the error rate. The point estimate is always going to be, when we're estimating the mean, which is almost always what we do, the average. I'm doing Control Shift down here to highlight them all. The critical value, well, let's see if I can remember. It's norm.s.inv, if I remember correctly. And then we had 2, remember the bottom end and the top end. The bottom end was just alpha over 2 in there for the probability. And then the top end, I can just copy all this, and escape gets me out if I'm stuck selecting a cell. And then it's just 1 minus this E1 over 2. Standard error, stdev dot s for the sample. Again, Control Shift down. Oh, excuse me, that's not what I wanted. I wanted standard deviation. Now, I will say when I'm trying to do, I want to move this down. If I click and drag this down, it actually gives me a different number because it changes the cells that it's referencing. So I don't want to do that. But if I click and highlight the stuff in this bar here and copy it, and then go down, escape again to get out of that, go down and paste it into that, it'll keep the exact same cells that I'm referencing. So this number will be the same. I'll delete that number for the standard error so that I don't get confused later on. For sample, I want the count of all of these, enter, and then the standard error. Well, for standard error, that is the standard deviation divided by the square root of the sample size. So again, I hope you're getting used to calculating these 3 pieces. That's the whole point of this, is that at the core, inferential statistics involves 3 pieces: a point estimate, a critical value, and a standard error. At least classic methods do. And so for these 3 pieces, they're the same calculation every time. So the same calculation every time that, as you saw in previous problems, I'm kind of just copying and pasting the data over it and just redoing these calculations based off it. It's a standard deviation, a sample size, and these give me the standard error. The point estimate is just the average, and the critical value is just based on that alpha level. And so we're just combining these components to help make a decision or create a reasonable range of values. So for our confidence interval formula, if I go back to my notes, and remember this was the point estimate minus the critical value, or plus or minus, I'll do this cell minus this cell plus, but remember minus is the same thing as adding a negative number. So I'll add the negative critical value and then times the standard error. So point estimate minus the critical value times the standard error, which is here. I'm adding the negative critical value, and then point estimate plus the positive critical value times the standard error. And this gives me the bottom and top end. Now, all these have been asking for the upper one, but this one says just give the low one here. So I'm going to have my low confidence interval and give that here. Very cool. All right, so wish to determine ED visits, reasonable range, create a 99% confidence interval. Okay, given some sample data, given the sample data below, what's the low number of this confidence interval? Again, Canvas doesn't like new numbers, so give the low one here. Okay, well, I'll do this. And I'm going to do the same thing, but I'll, I guess I guess maybe I'll do it again just in case. I'll do a new sheet and just redo all these. I'll do them sideways just to change it up a little bit. So for anybody who just wants to see it run through again, the process is kind of the same every time. So I'll go back to my previous sheet just to remember alpha, point estimate, critical value, standard error, and then the pieces to calculate the standard error. So alpha, point estimate, critical value, standard error, and then the pieces, which were the standard deviation and the sample size. For this case, alpha is going to be 1% error rate, so 99% confidence, 0.01 error rate. Point estimate is just the average of my data. And I think I have some more numbers here. I guess I can't see it down there, but let's see how many I have. I'm going to do Control left to take me to the beginning. Control Shift right to take me to the end. I see I've got 31 numbers here. The critical value, well, this is that same norm.s.inv. And again, I do alpha divided by 2. That's that 0.005 on the left side, half of a percent, less than 1%. And then norm.s.inv, same thing, 1 minus alpha over 2. And all I'm doing here is the 1 minus makes it the upper tail 1. Essentially what it's asking you to do is instead of putting the 0.005 on the right hand side, put 0.995 on the left hand side. So the 1 minus is the opposite in a standard distribution of that number. All right, not going to make the same mistake again, so leaving standard error blank, do the standard deviation, stdev-s, go up here, select, over, enter, count, tab, and then I'm going to go up here, control left to go to the left, control shift right to go to the right, close parentheses, enter. Ooh, except that looks like a negative. That doesn't look right. So I'll mention gut checks are hugely important, and I mean, it's going to be really awkward if I submit the quiz and I get all these problems wrong, but outside of that, like looking at this, a sample size, well, this is how many things you have. This should not be a negative number. And if you put in a negative number, you're going to get some weird results on some of the stuff. In fact, I think if I left it like this, let me see what happens if I leave it like a standard deviation divided by the square root. I think it might give me an error here and say, yeah, you can't do that. Essentially what it's saying is the square root of a negative number does not exist. So your formula would be correct, and that's exactly what you should have, but it will give you something that's not right. And the gut check that I need is if I'm just counting things up, that should not be a negative number. So if I fix that, standard error looks right, and now I've got all of my components. So I do want to make sure, double check, I'm putting a lot of work into this, that I'm getting the confidence interval here. So yeah, 99% confidence interval, given the generated below. What's the low number of the confidence interval? So confidence interval, well, I need my point estimate minus the critical value times the standard error, but again, we're generating a negative one, so it's plus the negative critical value. If you wanted to, you could do minus the positive critical value if you prefer, plus and minus the positive critical value, but it's usually easiest to just do plus the positive or plus the negative for the low one and plus the positive for the upper one. This is just putting the distribution on the scale of the data for the low end and for the top end. So this is the low end one, this is the top end one. These are the distribution values, and then the formula takes these distribution values with the values from our data, the standard error based on the standard deviation and sample size of our data, and the mean calculation from our data, and uses these to put these distributional values on the scale of our data. That was one of our earlier questions. Now let's see, was I tricky and asked for the upper one here? No, okay, just the low one here again. Okay, great, so the low one here. So I'll just copy and paste. Fantastic. All right. So last question. Woo, this video's been getting kind of long. I'm getting tired. I don't know if y'all get tired doing these. We've probably been at this for better part of an hour here, so this has been a big assignment. I think this is our hardest assignment personally. Um, I hope everything else from here is much easier for you, but um, yeah, I think this is our hardest assignment. In any case, going from here, let's see. Hospitals felt emptier this year to determine if this is true. You decide to collect data and evaluate. Given the generated sample below and null hypothesized value, mu equals 7 empty beds on average. What's the p-value? Hence, it's between 0 and 0.10, so don't forget to do 1 minus. Okay, this is interesting. So I'll be 100% honest. I don't remember this at all. So I'm going to pause my recording and go check out the Excel video. If you're struggling with this, consider doing the same thing. Pause this, go check out the Excel video. Remember, you can always use the course videos when you're working through these quizzes. Um, and so that's exactly what I'm going to do is take a second and go do that. And if you want to work through it with me, go on, try that too. Try this problem out and see if you do it. If you can do it, you can try it out on with your quiz data, or if you feel like manually typing in a few numbers, hopefully it'll only take a minute or two. You can try it out with my data too. All right, so I'm coming back to this. Just took a minute watching this other video. I know it only a couple seconds past here. Looking at how do we do these p-values in Excel. I was really curious about this 1 minus thing. So remember, for the 1 minus thing, for how Excel calculates these values, it does not invert them by default. So if we have a positive test statistic, we have to do a 1 minus. And again, the trick here, the hint here is it's going to be between 0 and 0.1. So um, that's hopefully helpful for us. All right. So putting this in, let's see what we get. So I'm going to have to do essentially the whole hypothesis testing procedure because my p-value is based on the test statistic. So I'm going to put in my information p-values based on the test statistic. So I need to calculate the test statistic. To get the test statistic, I need the point estimate, and the test statistic, remember, is the null mu point estimate minus the null mu divided by the standard error, and then I need the components to get the standard error, the standard deviation, and the sample size. So the null mu for this case is going to be 7 empty beds. So this is that context for the problem, but different data. I need my point estimate. That's going to be the average. The standard error, and again, I'm not going to make that same mistake. It's that standard deviation. S, and Control Shift right, close parentheses, enter. And this is the count. Control left to go to the starting place, Control Shift right, close parentheses, enter. And then my standard error is going to be the standard deviation divided by the square root of the sample size. Cool. All right, and again, my test statistic, getting us to the starting place of the p-value. This test statistic, the numerator divided by the standard error. That standard error is at the bottom. In the numerator, I have the point estimate minus the null hypothesized value. So this is my test statistic. It is positive, and so that's why I'm getting this warning or this hint. Don't forget to do the 1 minus, and the final answer should be between 0 and 1.0. All right. So if I do my p-value, and again, for the test statistic when it's positive, the equation or the function, excuse me, in Excel is the norm s dist, and I put in my test statistic, and then I want that cumulative value to be true. I'm just hitting tab to accept that, but you could just type in true. And remember, this is going to be the upper version. I need to do 1 minus this for a positive test statistic to get that p-value here. So that's going to be my p-value for this problem, or excuse me, my initial starting place for the p-value for this problem. All right, so from here, the last thing that I have to do, again, this is kind of the starting place, or this is the p-value, but it's only the area to one side. So the 1 minus makes it the area to the right of this positive test statistic. But remember, we have to multiply this by 2. So I'm just going to do over here equals, and then take this number and multiply it by 2. And that gives me this value 0.58, and that's what I'm going to put into my answer, 0.58. That's my p-value. You could do it here, but remember, if you do it here, you need to wrap this in parentheses to multiply by 2, because you don't just want to multiply this last number by 2, you want to multiply the whole thing by 2. And that would work fine. You could wrap that in parentheses and do times 2. I'm not going to do that because I already did it here, and if I do it there, then that'll make this cell now wrong because it'll be times 2 twice. But either way is just fine. But don't forget the p-value. So the trick with this one, we had to calculate the test statistic, use this in norm s dist on the test statistic to get the starting place p-value. Because this is positive, I had to do 1 minus to get the smaller number, and then I had to multiply it by 2. So this is the culmination of all that work. This is the hardest problem, I think, in the course, quite frankly. And so, yeah, if you did that, hats off to you. Congratulations, great job. And that's great. But yeah, I hope this video was helpful for you in figuring out how to do these homework problems. So I tell you what, let's go on and click submit, see how we did. Hopefully we got some of these right. Yeah, it looks like we got, now it took us almost an hour. Again, this is a long video, I apologize. But looks like we got these right in about an hour. So that's good, and I'm glad. I never know. Again, this is just me sitting down on the computer and doing this in one take. So I'm glad this worked out, because it would have been a bummer to have to re-record this. But I do genuinely hope this helps you figure out how to do this. And again, I don't want to make this magic or mystery, y'all. I don't just know all this stuff off the top of my head. Some of the stat stuff I know, and hypothesis testing and confidence intervals for sure, because I use that all the time professionally. But things like what's the right function name in Excel, I'm going back to look at our class video to figure that out. And so again, I can't encourage you to do this. Again, you can refer back to the module when doing the assignment. So please feel free to do that. I can't encourage you enough to take advantage of that. So in any case, again, I hope this was helpful, and I wish all the best, and hope everybody out there is staying healthy. Again, apologize for my lack of health, but look forward to corresponding with you in the future. Let me also add, I think I said this earlier, to me, this is the hardest assignment in the course. So everything is downhill from here. Next week should be somewhat easier, and then I think y'all, again, this is a healthcare analytics class, but this is in a healthcare administration major. And so in the last few weeks, we start talking about more applicable stuff, where we'll look at a couple of things that different hospitals and hospital administrators were trying to study within their hospital. They found it interesting enough to write it up and publish it. And so we'll look at a couple of publications of some statistics we'll talk about and learn some more stuff, all based on the things that we've talked about here, and start looking at some of those write-ups. So I hope you find the last part of the course to be a little bit more applied as we move out of some of the equations and calculations and more into the application. How do we interpret this? How do we apply this? What does this stuff mean? And so for many students, again, I think you find this this part to be the hill, the highest, the most difficult part of the class, and hopefully the rest is a bit downhill from here.